Bonjour tout le monde et bienvenue. D'abord, je voudrais demander, vous me permettez faire la présentation en anglais parce que sinon, ça va être très dur pour vous et pour moi aussi. Okay, let's start. So what I want to present today is a little part of our stack that we use at Teads to ingest data from several sources into our data warehouse. First, let me say some words about Teads. We are one of the biggest ad tech company that serves for visual ads that are shown or presented on the open internet. So we bring publishers and advertisers together to show advertisements on websites of usually high quality publishers sites like newspapers and networks in general. So first, a little agenda. I want to quickly introduce you to the analytics parts of Teads. Then I want to tell you about what are the needs that or what we want to do future-proofing for our ingestion. And actually, the main part of this is a little dive into the history of our stack regarding the ingestion into the data warehouse. Those are, I will start with a point in time 3 years ago, and then I will show the evolution. And finally, I will also give an outlook what we are going to do to improve it more. Okay, analytics at Teads. BI and analytics, business intelligence and analytics at Teads. So what we are doing, we are bringing order into the chaos. Let me say this. So we have internal and external like services and emitters that emit events and events that are used to, that we need to have to bookkeep or to do the bookkeeping what is happening during when a publisher sells its place on the website and an advertiser buys this place in an auction. And we need to bookkeep that for several reasons, for our own business, but also for the reporting of the clients, so they want to know what happened. And this kind of bookkeeping happens by emitting a bunch of events. So we have about 150 regular events that are emitted. So from our own services, like let's say, we call it buying engine, for instance, it's the one that buys advertisement space in an auction. And also from the viewer, that we know that the viewer has watched an ad or even has clicked or had some interaction with an advertisement. So this one is then ingested in real time into a real-time streaming architecture, which consists of a big part of link service, and we put it then in an ordered manner, means that we put a certain schema to it into Kafka, which is a streaming service or a streaming storage, and afterwards we have the problem we want to ingest this data into our data warehouse, which is BigQuery. It's a Google managed, very powerful data warehouse based on column-based databases. And at the end, in this data warehouse, we prepare the data to be quickly queried for reporting and for our own business intelligence, so that we know what happens with the business, how are we doing, what needs to be done to reach our goals internally. And right now I want to talk about a little bit of that. But we are not our own clients here. We have all other internal clients that also use this data that is relatively recent for updating our models to improve the experience of an auction, for instance, like adapt the bidding strategy as real time as possible. So what needs to be future-proofed here? Once again, we have like the Kafka side, and on the other side we have a data warehouse, which is like a table-based format, right? So like partition tables that will be then where we aggregate certain values into data marts, or we call it roll-ups, and from them we create reports. And in between there's the ingestion service, so we go from streaming to like a more batched presentation, like a batch presentation. And we have the other clients as well, and what needs to be optimized. So main optimization parameters are, or what do we want to future-proof? We want to future-proof for growth, because as a business we need and we want to grow rapidly and constantly. And so what are the parameters that we want to increase, or that want to grow? We want to be optimized, not all growing, but we want to cope with a growing throughput. So the number of messages and also the payload will increase over time. Right now we are at max at 500,000 messages per second, where in the Kafka compressed version it's like 500 bytes per message. That can vary. It's a little bit less, I guess, here, but we want to optimize for latency. Right now the latency of this ingestion from stream to partition table is about 30 minutes. Depends on the traffic we have, so it depends on the daytime and on the time in the year. Then we want to, of course, optimize the cost. All these parameters are connected with cost, but I mean here like the infrastructure cost at the cloud provider that we use. So for instance, only the storage cost for this part is about 1,500 euros a day at the moment. And we also have like more softer parameters to optimize. We are reliability. So for instance, consistency and the reprocessability is important. So we want to be able to, if we found out that we had a problem in our ingestion, we would like to be able to go back in time and to redo everything without a big hassle and without a lot of duplication and manual work. So we want to be reprocessable, and consistency means we don't want to have duplication, but we don't also want to have missing data. So what we do at the moment is like we do at least once, so we can be sure that we don't have missing data, and we try to short-term deduplicate our messages. And also one optimization, long-term optimization parameter is maintainability. So a system, if it's too complex, it's a lot of work to, like if there are too many different dependencies, every change will have a lot of dev and DevOps work to get a new version running. And also this stacky reusability. So we don't want to necessarily learn every new apply every technology that's there, and it's important for instance, for onboarding new engineers at the company, that we have like a good number of stack technologies. And what is a big factor here is and whenever we have new business requirements, this will make a big influence all these parameters, and we are maybe not able to use the optimal solution because we need to cope with the requirements. For instance, like GDPR, where we have to be more serious about that in certain parts of the world than in others, and that will increase actually our costs a bit to separate those worlds. All right, let's dive a little bit. I don't have too much time to really deep dive, but I will show you like a little bit the architecture, how it was 3 years ago. So this is our Flink service that collects actually the data. It sanitizes it hydrates additional information, additional attributes, and does the deduplication, and also brings it into a certain form, so brings it into a certain schema that can be used afterwards, right, that we can rely on. And in this case, we had Kafka that was using JSON as a base, so we put JSON messages into the Kafka, and we have like those two paths that I showed. This is our ingestion, and we had the other for the machine learning jobs that need to have an overview of most of all of our events to react on what's happening in a timely manner. And for historical reasons, we were using, or also for performance reasons, we are using AWS for most of our services, for most of our clusters, and also for our data lake or object storage. And on the other side, we decided for BigQuery because of its power, sheer power, and all the possibilities to be our data warehouse. So yeah, we had like to bridge the two worlds. And what was happening, we used Dataflow, which is like a managed service from Google that's actually created for ingestion, for instance, into BigQuery. So do highly parallelized batch ingestion into BigQuery, but we have to bridge the two ones. There are no public endpoints for the Kafka service, so we did not do it. So we created a VPN, and this worked very well for a while. But over the time, you see like the ingested events per day from 2017 to almost today. So we have constantly growing events, number of events that are constantly growing, and we knew already at a certain time, sooner or later, we will hit the throughput limit of the VPN, so this has to go away. And what we did, we changed then the VPN and used S3 as an intermediate storage, because S3 has like open and public endpoints, and it's then pretty simple to ingest this. And we use kConnect, which is like a pretty easily configurable service, highly scalable to read from Kafka into several outputs formats like S3 or others. Yeah. But we still have those two parallel ingestion pipelines, which is not nice. And we also had the problem that before we didn't use kConnect, so we had custom fetchers, like a self-made service to ingest the Kafka messages, and that was not very stable. And so we worked on 3 problems: exchanging fetchers. Then we also worked to get the storage size down, right? So optimize for storage. And we had also the problem with Dataflow with this kind of structure that we had, like those are at this time were like, yeah, single objects in a flat folder, like every so and so many minutes of data into a folder. And we could not scale Dataflow any better. So we had to non-linearly increase. We had to non-linearly increase the number of endpoints here or of services of instances in order to cope with the increasing data that we had. And so that didn't happen in one day, but over time we changed the architecture and it looks like very much smoother. We all use Kafka Connect. We changed to a schema-based format, Afro, which is row-based for fast writing. And exists something like a schema registry where, so we don't have to save the schema in the Kafka. And the advantage is like we have about 175 or more attributes. So there's a lot. Schema is really big for us. So it's a really like a relief to not to send it with every message or at least with every chunk of message. So we have a schema registry and Kafka Connect reads it and transforms it into a column-based format, which is easier or better for querying. So for the reading side, and we put them all into hourly folders. Yeah, and since we used Spark cluster for the machine learning stuff, we used actually the same technology to parallelly ingest into BigQuery, which was much easier, but pretty fast developed and saved us a lot of money. And last step, we are still in the run, or we're still working on it. All the types of messages we have or events that we send around are not independent. Usually we have like event groups, and an event group I say is a group of events that belong to the same ad event, which means one ad at a certain place in the web space of a publisher for one viewer, and those are all together. And for historical reasons, we usually have per event all the attributes. I told it's like 175. We have so many attributes, and it's not necessarily because we know those events belong together. So the idea is, why not move the addition of the attributes to the very end as far as right as possible to save a lot of storage, and even finally, so we will come soon to save even some kind of hydration work that is not necessary to be done. And for that, we enrich all the events using just the reference event. So we could imagine like we have an IP that we get and we try to estimate the hydration, and we do this only for one reference event. And at the end, we know all the events that were emitted for the same ad will be hydrated or with a big join in Spark to enrich those events, and then we can still do all the kind of roll-ups and data mart creation without any hassle, but we save a lot of storage. And as I said, this hydration can even be moved in the creation of the reference event. So we even make our ingestion pipeline more stable, robust. So this is how it looks today, or how we would like to look at it. It's not exactly that. Not all machine learning jobs use the enriched part right now, because this adds another little bit of latency, and we don't want. And we are not. We are in the. Right now, we are working on it to get to check if all those jobs can cope with a little bit more of delay, right? So I think it's a much cleaner stack, and it's really, yeah, making us, enabling us to go for higher volume of event data. So lessons learned, VPN is like really not the way to go. And what I not told, or we did never use streaming, because streaming usually is, there's a cap, like BigQuery allows only so and so many messages per table, and yeah, time to stream, and we easily get over this cap. And the managed solution is not always the best fit. Like Dataflow, we did not really find out, after a lot of testing, did not really find out what's exact the problem, but it was really quick, much easier to just change to Spark EMR. Even with the Spark EMR, okay, I come to the end. With the Spark EMR, we can scale up and down. That's also a good. Oh, yeah. Or we are using a scalable EMR, so we have a little bit the same behavior like Dataflow. And yeah, we cannot evaluate all the optimizations immediately, right? So last slide, little outlook, what we are doing right now. We are implementing a real or a more reliable data lake. At the moment, we just have S3 in Parquet format. And we will put an abstraction table format over it, like Apache Spark, in order to be better in our schema evolution and to have like a kind of consistency guarantee. So reads and writes are atomically, and it makes it much easier to be sure that things work well. And we even have the possibility to time travel with that. Another step is that we looking into EMR serverless, so we will only pay for the time we are running the ingestion, and even more, for our S3 we are looking at to use another compression standard, set standard, which is a bit more performant for us. That's what I wanted to tell you, and if you have any question, feel free to ask me.